Okay, we want to divide the complex numbers 7 plus 3i divided by 8 plus 5i. So we would like to write this ratio as a single complex number in the standard form a plus bi, where a and b are both real numbers. So the key is to use the complex conjugate. So we will multiply this original fraction here by the complex conjugate of the denominator over itself. So the conjugate of 8 plus 5i is 8 minus 5i. You simply negate the imaginary part. 8 minus 5i, 8 minus 5i. So of course we're multiplying by 1, and so that doesn't change the value of the original expression. Now, in the denominator, when you multiply these conjugates, we have a plus b times a minus b is a squared minus b squared. So that's 64 minus, and then if you square 5i, you get 25i squared, which is negative 25. So this is minus negative 25. And in the numerator, we have to calculate 7 plus 3i times 8 minus 5i. But focusing on that denominator, the denominator is just a real number, and that denominator is 64 plus 25, which is 89. So we have a real denominator now, and we will simply divide that real number into the real and the imaginary parts of the result of the multiplication in the numerator. So let's move off to the side here and multiply 7 plus 3i times 8 minus 5i using the distributive property, the so-called FOIL method, first outside, inside, last. So 8 times 7 is 56. 7 times negative 5i is negative 35i. 3i times 8 is 24i. And 3i times negative 5i is negative 15i squared, which is positive 15. So we get 56 plus 15, which is 71. And then the imaginary part, we have negative 35i plus 24i, which is negative 11i. So in the numerator here, we have 71 minus 11i. So now we have a complex number divided by a real number, and we simply divide into each part. So the answer could be written as 71/89 minus 11/89 I. So that's the standard form, a real number plus or minus a real number times I. So that's our result, 71/89 minus 11/89 times I.